Joule's law in thermodynamics is primarily concerned with the internal energy of an ideal gas. It states, the internal energy of an ideal gas is solely a function of its temperature and is independent of its pressure and volume. In other words, if the temperature of an ideal gas remains constant, its internal energy does not change regardless of any changes in pressure or volume. Examples of Joule's law include the free expansion of a gas, known as Joule's experiment. When a gas expands freely into a vacuum without performing work or exchanging heat with the surroundings, its internal energy remains constant if the gas is ideal. For instance, consider a gas confined in one chamber of a thermally insulated container. When a valve is opened, the gas expands to fill the entire container. Since no work is done, and there is no heat exchange, the internal energy depends only on the temperature. If the temperature remains constant, the internal energy does not change. Another example is heating a gas in a rigid container. If a gas is heated in a sealed, rigid container, which maintains constant volume, the pressure increases, but its internal energy depends only on the temperature rise. For example, heating a gas in a cylinder where the piston is locked, as the temperature rises, the energy stored in the gas increases proportionally. Lastly, consider the expansion in a cylinder with heat addition. For an ideal gas in a piston-cylinder arrangement, if heat is added, causing the gas to expand and do work on the piston, the internal energy change still depends only on the temperature rise, not the change in volume. For example, gas used in an engine expands as fuel burns, but the change in internal energy aligns with the temperature change. It's important to note that for real gases, Joule's law does not strictly apply because the internal energy can depend on intermolecular forces, which are negligible in ideal gases.